Now see next question, question number 19. If a plus 3i upon 2 plus ib equals to 1 minus I, show that 5a minus 7b equals to 0. So we start from given part. Given part is a plus 3i upon 2 plus ib is equals to 1 minus I. So here we have to show 5a minus 7b equals to 0. That means we have to find the value of a and b or directly value of 5a and 7b. So first we find the value of a and b. For that we transfer this denominator to right hand side. Therefore a plus 3i is equals to 1 minus I into 2 plus ib. So multiply RHS first. So 1 into 2 we get 2. 1 into ib we get ib, multiply by minus I, so we get minus 2i plus minus minus b into I square. So write here 2 plus, taking I common from these 2, so we write here plus b minus 2 into I minus b into, replace I square by minus 1. So we write here 2 plus b minus 2 into I minus minus plus, so we write a real part with a real part. So a plus b minus 2 into I, and in left hand side we have a plus 3i. So you can transfer ab in one side or you can directly equate these two. So we equate by equality of complex number. So we write here by equality of complex number. So write here a is equal to 2 plus b, real part with real part, then b minus 2 equals to 3, or we write 3 is equal to b minus 2. So from this we get b is equals to 5. When we transfer this minus 2 to left hand side, we get 3 plus 2 5. So we write b equals to 5. Substitute this or put b equals to 5 in this equation. A equals to 2 plus b. So we get 2 plus 5. That means a is equals to 7. Now we get the value of b, a. So we show 5a minus 7b equals to 0. So we consider here LHS first. Therefore LHS is equals to 5a minus 7b. Now substitute the value of a as 7. Minus 7 into substitute the value of b as 5 into 5. So 5 7 are 35. Minus 7 5 are 35, which is equals to 0, which is equals to RHS. So in this way we show 5a minus 7b equals to 0. Now see question number 20. If x plus iy equals to a plus ib upon c plus ib in root, do that x square plus y square its square equals to a square plus b square upon c square plus b square. So given part is x plus iy here. That means we have to find x square plus y square first, then taking its square. So we first write this as, so we write in given part x plus iy is equals to square root of a plus ib upon c plus id. So taking square on both sides, so we write here taking square on both sides. So we take square here. So write square of x plus iy in right hand side. So in right hand side square and square root get cancelled. So we write a plus ib upon c plus id. So we write square of left hand side here. So apply the formula a plus b bracket square. So we write here x square plus twice xyi plus I square y square is equal to a plus ib upon c plus id. Now, so take conjugate of RHS for solving RHS. So a plus ib we multiply and divide by conjugate of c minus conjugate of c plus id, which is c minus id. So in left hand side we write here x square plus twice xy I square is minus 1. So we directly write minus y square. Now multiply numerator terms with numerator terms. So a into c we get ac, a into id we get ADI, then multiply by ib, so we get ib into c, that is BCI minus, here I into I square, b into d bd, so we write minus bd I into I square, upon we apply the formula a plus b a minus b, so we write here c square minus I square b square. Now write a real part with a real part. So x square minus y square is a real part plus twice xyi is imaginary part. So here also AC. Here if we replace I square by minus 1, so this minus minus get plus, so we write here plus BC. So that a real part we write with this AC. So we write AC plus BD. Then we have to take minus sign common from this second and third term. So we take I common, we write first term BC, then minus AD, and we take I common. In denominator we write c square minus, I square is minus 1, so we write minus minus plus into d square. So we write here c square plus d square. Now separate the base, we write AC plus BD upon c square plus d square, this is real part, BC minus AD upon c square plus d square into I, this is imaginary part. So we equate these two complex numbers, so we write here, therefore by equality of complex number we write x square minus y square is equal to AC plus BD upon c square plus d square, and imaginary part is twice xy, so write twice xy is equal to BC minus AD upon c square plus d square. Now we require the value x square plus y square. Now we have to show that x square plus y square its square is equal to, we have to show this is a square plus b square upon c square plus d square. So we substitute the value in LHS, but we require the LHS in the form of x square minus y square and in the form of xy. So for that we reduce LHS in the form of x square minus y square and in the form of twice xy. So for that we use the formula a plus b bracket square is equal to a minus b bracket square plus 4 times a into b. So here in place of a value is x square, in place of b value is y square. So we write this as x square plus y square its square is equal to a square, x square minus y square its square plus 4 times in place of a x square, in place of b y square. That means we have to find the value of x square plus y square, but we have calculated the value in the form of x square minus y square twice xy. So we replace this x square plus y square in terms of x square minus y square its square plus 4 times x square y square by using this concept which you already studied in algebra in class 10. So we use this concept. So substitute the value of x square minus y square, that is AC plus BD upon c square plus d square its square plus 4 into, so this 4 we write as 2 square, so we write directly right here, or you can add one step, for your convenience, then we substitute the value. So we write here x square minus y square its square plus this we write in 1 square xy its square. Now substitute the value of x square minus y square as AC plus BD upon c square plus d square its square plus twice xy we calculate BC minus AD upon c square plus d square its square. Now we write the numerator square separate, denominator square separate. So we write AC plus BD its square upon c square plus d square its square plus here also BC minus AD its square upon c square plus d square its square. Now in both the terms base is same, so we write base same separately, c square plus d square its square. Now apply the formula of a plus b bracket square. So we write here a square c square plus 2 times AC into BD plus BD square, that is b square d square, then plus square of this. So again we apply the formula a minus b bracket square here. So we write b square c square, that is square of first term minus 2 times BC into AD, that we rearrange, or you can write as it is BC AD, then square of AD. So we write here a square d square. Now observe the terms here plus twice ABCD. If we rearrange this we get twice ABCD. Here also if we rearrange we get ABCD, but here sign is negative, here sign is positive, so we cancel this term. Now next we require c square plus d square, so we find the value from which we can take commons. So here a square c square, here a square d square, so we take a square common from first and last term. So we write here a square in bracket c square plus d square. Then from this b square d square c square we take b square common. So we write here b square in bracket. If we take b square common we write here b square. When we take b square common we write here c square upon c square plus d square its square. Now again this c square plus d square, here d square plus c square we take common. So we write here a square plus b square, or we write this c square plus d square common. When we take c square d square common, c square d square common, the coefficients are a square plus b square. So we write in second bracket a square plus b square upon c square plus d square its square, c square plus d square its square. That means this c square plus d square its power is 1. So this c square plus d square get cancelled with 1, c square plus d square. So we get the value a square plus b square upon c square plus d square, which is RHS. Hence proved, or hence show x square plus y square its square equals to a square plus b square upon c square plus d square. Now see next question, question number 20. If a plus ib equals to 1 plus I upon 1 minus I, then prove that a square plus b square equals to 1. So we use given part. A plus ib is equal to 1 plus I upon 1 minus I. So you can solve this problem by two ways, either transferring this 1 minus I to left hand side or taking conjugate of this 1 minus I. So we solve it by taking conjugate of denominator. So 1 plus I upon 1 minus I. So we write here 1 plus I upon 1 plus I. So multiply and divide by conjugate of denominator. Now multiply the numerators with numerator. Now 1 plus I into 1 plus I, which is 1 plus I its bracket square. In denominator we write 1 minus I, 1 plus I as 1 square minus I square. So we use the formula a plus b bracket square here. So we get 1 square plus twice 1 into I plus I square upon here 1 square is 1, I square is minus 1, so minus minus plus 1. 1 square is 1 plus 2 into 1 into I, that is 2I square is minus 1 upon 1 plus 1 is 2. So this plus 1 minus 1 get cancelled. 2I upon 2, which is equal to I. So we write here, therefore a plus ib is equals to 0 plus 1 into I. So equating the real part with real part. So we write here, by equality of complex number, a is equal to 0, b is equal to 1. Therefore we have to show a square plus b square equals to 1. We have to show a square plus b square equals to 1. Therefore we consider LHS here. LHS equals to a square plus b square. Now substitute the value of a as 0, substitute the value of b as 1, so 1 square. So we write here 1 square as 1, which is equals to RHS. So this type of problem we already solved. So you can solve this problem